Okay, let's unpack this. CSS, for years, has had this reputation among developers, hasn't it?
Yeah,
Like maybe a bit complex or something you'd rather use a preprocessor for, or maybe, Tailwind or something similar.
definitely. It felt like you needed those extra tools like SAS for things, well, things like nesting that we kind of take for granted now.
Right.
And to be fair, for a long time, those tools were plugging real gaps in what native CSS could do.
But well, the landscape's really shifted. It's 2025 now, and the sources we're looking at today, they argue pretty strongly that native CSS itself has been improving incredibly fast.
Yeah. Yeah,
Features that maybe felt like sci-fi or needed complex JavaScript hacks before, they're just, well, they're in the language now.
absolutely. The standards are evolving quickly. And look, abstractions still have their place, for sure.
Mm-hmm.
But really understanding and using what native CSS offers today, that's becoming, I think, more and more crucial for writing good, solid, accessible styles.
So that's our mission for this deep dive then. You've given us this great set of materials focusing on some of these really powerful modern CSS features.
Yep.
And we're going to try and pull out the key stuff, the most important bits, to help you get up to speed fast on what's new, why it's useful, and, well, why it matters.
Sounds good. Let's get into it.
All right, so first up, a classic problem. Making elements size properly on different screens, responsiveness. Used to be a lot of like percentage maths or fiddly
Right,
breakpoints.
exactly. And that's where these newer functions really shine.
Mm-hmm.
Min, max, and clamp. They give you way more control right inside the CSS value itself.
Okay, so how does min work? What does that help with?
So min basically sets an upper limit. It looks at the values you give it and picks the smallest one.
Okay.
The material uses this example. Pricing button with lin, 300px, 90%.
Right.
So the button tries to be 90% wide, but only up to a point.
Mm-hmm.
If that 90% calculates out to, say, 400 pixels on a big screen, and compares 300px and 400px and says, nope, 300px is smaller, so it caps the width at 300.
Oh, okay. So it stops things getting too big. Makes sense. And max the flip side, a lower limit.
Exactly. Max makes sure something doesn't get too small. It picks the largest value it's given. The source uses typography for this one. Terms-container font size, max, 16px, 1.2 VW.
So the font size has to be at least 16 pixels.
Precisely. On a really narrow screen, maybe 1.2 VW, that's 1.2% of the viewport width, might calculate to something tiny, like 10px.
Yeah.
See 16px and 10px and picks 16px. So your text never becomes unreadably small.
That's great for accessibility, minimum readability. Okay, so min for the ceiling, max for the floor, and clamp kind of puts them together.
Yeah, a clamp is brilliant. It takes three values: a minimum allowed value, a preferred or ideal value, and a maximum allowed value.
Yeah.
The example they give is for a title. Dashboard title, font size, clamp, 1.5 rem and 5 EW, 3 rel.
Well, it tries to use 5 EW.
Yeah, it tries to scale the font size based on the viewport with 5 EW.
Yeah.
But clamp guarantees it won't ever go below 1.5 rem, no matter how small the screen.
Uh-huh.
And it won't ever go above 3 rem, no matter how huge the screen is. It creates this really smooth, fluid scaling, but within safe boundaries.
Yeah.
Super useful for responsive text.
Yeah, that feels way better than just having specific font sizes jump at different breakpoints.
Definitely.
And speaking of sizing, units have come a long way too, right? It's not just pixels anymore.
Not at all. I mean, px is technically relative itself, depending on screen density.
Yeah.
But yeah, most other units are relative to something else. Font sizes, the viewport, even character shapes. The sources mentioned quite a few.
Like the font-based ones, we know M and Rem, but what about things like X or Kh?
Right. M is relative to the parent element's font size. Rem is relative to the root element's font size. Those are pretty standard. But yeah, the notes also bring up X. That's relative to the X height, like the height of a lowercase x in the current font.
Yep.
And ich, which is usually based on the width of the zero character of the font. These can be handy for, say, sizing containers based on how much text might fit, or aligning things visually.
Interesting.
Oh, and ek for the line height, too. The key thing the source mentions here is that font relative units like M, X, and ek can sometimes behave a bit differently depending on what property you use them on, like font size versus width or margin. Something to keep in mind.
Good point. Okay, and then we have the viewport units from CSS3, VH, VWs, Vmin, Vmax. Those are based on the window size.
Yeah, great for full-height sections or things that need to scale directly with the browser window. But even those have evolved. Since around 2022, we've got these newer ones, DVH and DVW, for dynamic viewport size.
Dynamic.
Yeah, think mobile browsers where the address bar or toolbars might appear or disappear as you scroll. DVH and DVW adjust to that changing visible space.
Okay. That's always been tricky.
Exactly. Then you have CSOVW, for the small viewport height width, like when toolbars are visible, and LVH/LVW for the large viewport when toolbars are retracted.
Mm.
These give developers much more reliable ways to measure the actual available space, especially on mobile.
Okay, so much better ways to handle sizing, more precise units. Let's shift to layout. Traditionally, layout changes mostly relied on media queries reacting to the browser window size, right?
Yeah, which is fine for the big picture, the overall page structure.
Yeah.
But what if you have a component, like a card maybe, and you wanted to change its layout when its container gets wider or narrower, regardless of the whole browser window?
Right. That's the perfect scenario for container queries, isn't it? The sources really stress how this lets components react to their own space.
Precisely. It makes components truly self-contained and reusable. You basically tell a parent element, hey, you're a container, using something like container type, inline size. Then inside that container, you write a container rules that look a lot like media queries. The example shows a dot cards wrapper holding several dot card elements. Maybe the default dot card style stacks things vertically, but then you add a container with 200px dot card flex direction dot row, other horizontal styles.
So the individual cards flip to a horizontal layout only when the dot cards container itself gets wider than 200px, even if the whole page is still narrow.
Exactly. The component responds to its immediate context, not the global viewport.
Yeah.
It's a massive step forward for component-based design.
Makes so much sense for reusable UI pieces.
It really changes how you can think about structuring things. And sticking with queries for a second, the sources also mentioned a syntax improvement for media query ranges.
Oh, right, just making them cleaner to write.
Yeah, basically. Instead of the slightly wordy at media min width, 768px, and max width, 1199px.
Which always felt a bit clunky.
Right. You can now use a more mathematical comparison at media, 768px with 1199px.
Ah, nice.
Or simpler ones like at media with 768px. Or at media with 1200px.
Yeah.
Just less typing. A bit more readable, perhaps.
Yeah, that's a neat quality of life improvement. Okay, let's talk text and color. The materials highlight text wrap. What's that about?
Yes, specifically two values, balance and pretty. They're designed to make text flow better, improving readability by controlling line breaks more intelligently.
Okay, and balance is mainly for shorter things, like headings.
That's the idea, text wrap. Balance tries to make lines in, say, a heading have roughly similar lengths. You know how sometimes you get one really long line and then a very short one?
Yeah, it looks unbalanced.
Exactly. The comparison shown for welcome to our platform makes it clear balance adjusts the breakpoint to make the lines look even more composed.
Nice. And pretty is for longer text paragraphs?
Yep. Text wrap.
Oh.
Pretty aims to prevent orphans.
Orphans.
Yeah, those single words left dangling on the last line of a paragraph. It looks a bit awkward typographically. The example text, this is a long description about the features we offer, without pretty might end with just offer on its own line. With pretty, the browser tries harder to adjust the line break slightly earlier in the paragraph to avoid that lonely word. It's subtle, but makes paragraphs look more polished.
Little details that improve the overall feel. Okay, how about color? The sources mentioned CSS relative color syntax?
Oh, yeah, this is powerful stuff.
Yeah.
It introduces a from keyword inside color functions like HSL or RGB. It lets you grab an existing color, maybe from current color, or a CSS variable, or just a hard-coded color, and then tweak its individual components, hue, saturation, lightness, alpha, whatever, using calc or other functions, potentially even within a different color space.
So you could take your main brand blue, for example, and easily create a lighter, maybe slightly less saturated version for a hover state directly in the CSS.
Exactly. No more guessing hex codes or pre-calculating variations. The examples show things like HSL, from current color HSL, to get the components of the current text color. But the real magic is in transformations like HSL, from hashtag 0000FF, cal plus 60, calcul 18, calcul 1.2. This takes pure blue, hashtag 000FF, gets its HSL components, then calculates a new color by adding 60 to the hue, multiplying saturation by 0.8, making it less saturated, and multiplying lightness by 1.2, making it lighter.
Wow, that's much more declarative than messing with color mixers or Sass functions.
Yeah, it makes deriving related colors really intuitive. And speaking of color modes, there's also the light-dark function.
Right, that seemed like a handy shortcut for light and dark themes.
It is. It avoids needing a full at media, prefers color scheme, dark block for simple color swaps.
So like background, light dark, hashtag F1, F5, F9, hashtag 0, F172A, just sets the light mode background first, then the dark mode one.
Exactly. Light value, then dark value, separated by a comma. And the examples show it works for any color property background, text color, borders, and with different color formats too. Super simple for basic theme switching.
Cool. And related to that is the color scheme property itself. How does that differ?
Color scheme is more about telling the browser what themes your page or component supports. This is key for getting native UI elements, scroll bars, form inputs, buttons, drop-downs to automatically adapt their appearance.
Ah, so you tell the browser this page works in light and dark mode, like with .root color scheme, but dark light.
Precisely. That signals global support. Putting dark first can sometimes suggest a preference if the browser allows, but the cool part is you can scope it. The source shows .themed color scheme.light.
So even if the user's OS is set to dark mode,
That specific card
yeah,
and any native elements inside it, like an input, will stick to the browser's light mode rendering.
right?
Or you could have a code editor component always use color scheme.
Dark, dark.
It gives you fine-grained control over how browser-native UI looks within your design.
That's really useful for consistency when mixing custom styles with native elements. Okay, let's talk structure and organization. There's a new way to handle margins and padding. Logical properties.
Yeah, things like margin block and padding inline, these are designed to replace the physical top, right, bottom, left properties.
Why the change?
It's mainly about handling different writing modes more naturally. Think left to right versus right to left languages, or even vertical text someday. Margin block always refers to the start end in the block flow direction, usually vertical. And padding inline refers to the start end in the inline flow direction, usually horizontal.
So instead of margin top and margin bottom, you just use margin block.
Often, yes.
Yeah.
Or margin block start and margin block end if you need specific sides. Same for padding inline start, padding inline end. The big win is they automatically adapt. If the text direction changes to RTL, padding inline start correctly applies padding to the right side without you needing extra CSS. Makes internationalization easier.
That seems much more robust. Okay, now, this next one feels like a really big deal for CSS selectors.
Oh, it absolutely is. A total game changer. For the first time, lets you style an element based on what's inside it. You can select a parent or an earlier sibling based on its descendants.
Which was basically impossible before without JavaScript, right?
Pretty much, yeah. We're adding specific classes to the parent manually.
So what kind of things can you do? The examples mention styling a card if it contains an error.
Exactly. .card.has, .error-message, border-color.red.
Hmm.
The .card itself gets the red border only if it has an element with a class error message somewhere inside it.
Wow.
Another great one is .form-group.has, input required. You can add like a little asterisk or change the label style for the whole group just because it contains a required input field. It lets you style based on state or content much more dynamically.
That opens up so many possibilities. Feels like it solves a whole category of problems. And another feature borrowed from preprocessors is now native. Nesting.
Yep, finally. Just like in Sass or Less, you can now nest selectors inside their parent rules in native CSS.
So like the .card example, again, you define .card, and then right inside that block, you can put and.header for a child or and.hover for a state.
Exactly. The int represents the parent selector. You can nest direct children, pseudo classes like .hover, combine selectors like and.title and subtitle, and even nest at media queries inside the component's rule block.
That seems great for keeping related styles physically together in the style sheet.
It really helps with organization and understanding the structure, especially for component-based approaches. It reduces the need for methodologies like BEM that were partly invented just to cope with the lack of native nesting.
Makes sense. Okay, one more organizational tool mentioned was @layer. What problem does that solve?
@layer is all about managing the C in CSS, the cascade, specifically dealing with specificity conflicts. It lets you define distinct layers for your styles.
Layers, like base styles, components, utilities.
Exactly like that. You define the order of your layers up front, maybe something like @layer reset, components, utilities.
Okay.
Then you wrap your actual CSS rules within blocks for each layer.
Mm-hmm.
@layer reset styles, @layer component styles, @layer utilities, utility classes.
And how does that help with specificity?
Here's the key. Styles defined in a later declared layer will always override styles from an earlier layer, regardless of the selector's specificity.
Whoa, really? Regardless of specificity?
Yep. So in that example, a simple utility class like JAP4 defined in the utilities layer could override a more specific padding rule defined on #sidebar.widget inside the components layer, just because utilities comes after components in the @layer definition. It provides a very predictable way to control which style sources win, reducing cascade confusion.
That sounds incredibly useful for large projects or when you're mixing your own styles with third-party frameworks or utility libraries.
It really is designed to bring more explicit order to the cascade.
Okay, last section, animation. There was a specific problem with animating elements that use display. None.
Yeah, animating things like modals or drop-downs that appear and disappear. If an element starts a display, none. It's completely removed from the layout and rendering. So when you switch it to display block or flex, there's no before state for properties like opacity or transform to transition from. The animation often just wouldn't run or it would snap instantly.
Oh, okay. And at starting style is the fix.
It is. It's
Oh,
quite elegant, actually.
yeah.
A starting style lets you define how an element should look for the very first frame after it stops being display, none, or contents, etc., and becomes visible.
So it provides that initial state for the transition.
Exactly. The modal example illustrates it well. You might have .modal display .none, opacity 1, maybe set opacity 1 when closing modal .open display .block, opacity 1 transition, opacity be set 2 threes.
But just doing that, the fade-in wouldn't work when opening?
Correct. So you add its starting dash style, modal.open, opacity 0, 0. Now, modal.open makes the element display dot. The browser applies opacity, 0 just for that initial render, and then the transition defined in .modal.open kicks in, animating the opacity from 0 to 1 over 0.3 seconds.
That's brilliant. It bridges that gap perfectly.
It solves a long-standing annoyance with CSS animations very cleanly.
Wow. Okay, we have covered a lot of ground there. Seriously impressive evolution in CSS. From those sizing functions, min, max, clamp, and the new viewport units, to layout powerhouses like container queries, the text wrapping, relative colors, the light-dark function, color scheme.
Logical properties, the
Yeah.
selector, which is huge.
Huge. And nesting, at layer for cascade control, and finally at starting style for smoother animations. It's quite a list.
It really shows that CSS is far from static. It's becoming incredibly capable.
And that was the goal here, right? To distill those key features from the sources, give you that quick overview of what modern CSS can do. Hopefully this deep dive helps you feel more current.
Yeah, knowing this native stuff is just so fundamental now, even if you do use frameworks on top. It informs how you use those tools too.
Absolutely. Which leads us right into that final thought, building on what the sources were getting at about core CSS knowledge. Given how much power is now baked directly into native CSS, how might that change your approach to building web interfaces? What does this ongoing evolution mean for the future of all those tools and frameworks that, well, originally popped up to fill the gaps that native CSS is now increasingly filling itself? Definitely something to chew on.